Hi, my dear students. Welcome to India's biggest online platform, Yummy Educational Institutions. Today, we are going to start a wonderful session that is numerical session on thermodynamics 1. In this session, we can solve some problems based on thermodynamics. Let's start the session. Read the question carefully. A rigid nitrogen tank stored inside a laboratory has a pressure of 30 atmosphere at 6 am when the temperature is 27 degrees centigrade, and at 3 pm when the temperature is 45 degrees centigrade, the pressure in the tank will be dash atmosphere. Nearest integer. This question given in JEE Mains 2022 shift 2. First, try to read the question and understand the given data and try to write down complete given data, then apply your fundamentals of thermodynamics to solve the problem. First, read the question carefully. A rigid nitrogen tank. A rigid nitrogen tank. The term rigid is given. That means volume is constant. Volume of the nitrogen tank is not changing. They recorded pressure and temperature at 6 am and 3 pm. I am taking 6 am as initial conditions, 3 pm as final conditions. Here initial pressure will be 30 atmosphere, initial temperature 27 degrees centigrade. At 3 pm, that is the final state of the gas, because we are we are analyzing the nitrogen tank between 6 am and 3 pm. Temperature 45 degrees centigrade, then what will be the pressure in the tank? So see the given data in the proper manner. See here, parameter, what is the initial pressure? Pressure at 6 am, 30 atmosphere. Temperature at 6 am, 27 degrees centigrade. And final temperature, 45 degrees centigrade at 3 pm. Final pressure at 3 pm, what is the pressure of the gas present inside the tank? Understood now? So that part we need to calculate. What is given in the question? A rigid nitrogen tank, that is why volume is constant. Volume is constant, then pressure will be directly proportional to temperature. So here I want to convert degree centigrade into absolute thermodynamic scale, that is Kelvin scale. Okay, so here what is given? Tell me. T1 equals to 27 degrees centigrade. How to convert it into Kelvin? 27 plus 273 equals to 300 Kelvin. First try to convert entire part into these two temperatures into absolute thermodynamic scale. 45 degrees centigrade, here it would be 45 plus 273. Here it is how much? 5 plus this 8, and then 270 plus 40 will be 310. So 318 Kelvin. I converted initial and final temperatures into absolute thermodynamic scale. So if volume is constant, here volume is constant, then pressure is directly proportional to temperature. Pressure will be directly proportional to temperature, then P equal to some constant into temperature. So I can say that this, you can say constant generally in thermodynamics, this is the constant. P by T equal to constant. P by T equal to constant. Then I can say that I can directly write here P1 by T1 equals to P2 by T2. P2 by T2. So you can write it as P2 by P1 equal to P2 by P1 equal to T2 by T1. T2 by T1. So finally, what is the pressure P2? What is the pressure P2? We need to calculate T2 by T1. T2 by T1 into pressure P1. Okay, so in this manner, you will be calculating pressure P2. Finally, will be getting P2 in terms of atmosphere. Here, P1 by P2 equal to T1 by T2, or else P2 by P1 equal to T2 by T1. Now we can substitute the given data in order to calculate P2. See here, thus would be given data. Now P2 by P1 or P1 by P2 equal to T1 by T2. From here, just now we had a discussion. Here we will be getting P2 equals to T2 by T1 into P1 into P1. Here you can write T2 as, what is T2 here? You converted it into Kelvin, 318 Kelvin. What is T1? 300 Kelvin into, what is P1? 30 atmospheric. This is 30 atmospheric pressure. So once you cancel it, what do people are getting? Here, this is 30, this would be 30, and then you can, this would be, it will become 10. Understood now? It will become 10. Then what is the pressure finally? What is the pressure finally? 31.8 atmospheric. 31.8 atmospheric. 30 tanja, here you will be getting. So it is approximately equal to 32 atmospheric. Okay na? So this is the pressure P2. They are asking pressure at 3 p.m. Pressure at 3 p.m. That is 32 atmosphere. Final answer to this question, P2 equals to 32 atmosphere. This is pressure at 6 p.m. Pressure in the rigid tank at 3 p.m. Pressure at 3 p.m. This would be 3 p.m. Understood now? So this is the way to solve this problem. So rigid tank is given, that means volume is constant. You can directly apply the proportionality. From here, P2 equal to T2 by T1. You can write this part as, we already know that, you can write it as P2 by P1 equal to T2 by T1. But only thing you need to remember, you need to know, these two temperatures must be from absolute thermodynamic scale. Okay, don't forget to convert it. Understood na? So it is very simple to solve the problem. Final answer to this question is what? This is the given data and this is the formula used. Final answer is 32 atmospheric. So we used this expression P2 equal to T2 by T1, T2 by T1 into P1. So both temperatures must be up from absolute thermodynamic scale. This is the way to solve this simple problem. Now we can have a look on the next question. Read the question carefully. 1 gram of liquid is converted to vapor at 3 into 10 power 5 Pascal pressure. If 10% of heat supplied is utilized for increasing the volume by 1600 centimeter cube. During this phase change, this is the phase change. Generally, phase change occur at constant temperature and at constant pressure. This is the constant pressure. At this particular pressure, okay, now phase change will occur. Here, this is called latent heat. latent heat. This is saturation pressure. Saturation, at this saturated condition, this liquid converted into vapor. Then the increase in internal energy of the process will be. First, write down the given data, then try to solve the problem. This is the question from application of first law of thermodynamics. See here, what is given? Mass of the liquid is 1 gram of the liquid. Pressure P equal to 3 into 10 power 5 Pascal. This is 3 bar actually. So 3 into 10 power 5 Pascal. At this pressure, phase change will occur. During phase change, pressure will be constant. At this constant pressure, liquid converted into vapor. And one more thing, increase in volume. Here 10% of the heat is supplied to utilized to increase the volume. That means 10% of heat supplied is utilized to do the work. Understood now? What is the work done here? PdV work. PdV work is nothing but 10% of heat supplied. Now, work done is nothing but 10% of heat supplied. Next is increase in internal energy. What is the increase in internal energy? TU, they are asking you to determine. See here, you need to know that, you should know that here what is the work done. W equals to PdV. Okay now, so this is the work done. Okay, so what is given? 10% of heat supplied, 10% of Q is given. That means 0.1 Q, 0.1 Q. W equal to 0.1 Q. Q equal to, what is Q? Tell me. What is Q? Tell me. 10 W. W by 0.1. So now we need to apply first law of thermodynamics. This is the given data. You can apply first law of thermodynamics. And before that, what is the first law of thermodynamics? What is the first law of thermodynamics? Del Q. This is del Q equals to Tu plus del W. So work done and heat transfer both are inexact differentiable. So here what is given? What is given? Del Q. This would be del Q. Integral of del Q is nothing but total heat supplied. Integral of del W, you can take it as total work done. Total work done. What is the total work done here? What is the work done? I can say PdV work. That is the work done. What is the pressure here? I can write it as, this is the pressure, 3 into 10 to the power of 5 Pascal means Newton per meter square. What is the increase in volume? 1600 into 10 power minus 6 meter cube. Meter cube, finally you will be getting, this is how much? This is how much? Total, here you can cancel it, 10 power 5 and this and 10 power 6. 10 power 6, both will be cancelled out. Understood now? So now 3 into 160 Newton meter. Newton meter is nothing but 16 3 ja 48. 480 joules you will be getting. W equal to 480 joule. W equal to 480 joule you will be getting. Now I want to apply first law of thermodynamics. If you integrate it, this is the thing. Here, what is the heat transfer? What is the heat transfer Q? It's very simple. We already discussed that part. W equal to 10% of heat supplied, 0.1 Q. What is Q here? 10 W. 10W is nothing but how much? What is 10W? 10 into 480. That means 4800 joules. This is the heat supplied, total heat supplied. This much amount of heat is supplied, but here 10% of heat supplied is utilized to do the work. Q, basic form, Q equal to Du plus total work done. Total work done, total heat transfer. Finally, Du equals to increase in or change in internal energy. So that is nothing but Q minus W. What is the Q here? What is the Q here? 4800 joules minus work done 480 joule. So once you subtract it, what you will get? Tell me. 4800 minus 480. So here 4320 joule you will be getting. This is the change in internal energy. Change in internal energy. Understood na? So in this manner, this is the final answer to this question. Very simple to calculate. First try to calculate the work done. This is the work done. PDV work, pressure is constant here. Change in volume here, increase in volume. So finally 480 joules. So work done is positive here because increase in volume means work done by the system and work done is positive. So here you are getting W equal to 0.1 Q, Q equal to 10W. Finally, we substituted everything in the first law of thermodynamics. Then you got Du equal to 4320. This is the answer. Given data. What are the formulae used here? W equals to PDV, pressure constant, and what is the, and one more thing, Q equal to first law of thermodynamics, Du plus W. Okay na? So here Du increase in increase in internal energy, change in internal energy equal to Q minus W. Q minus W. Q is nothing but 10W. So that is the given data. Q W equal to 0.1 Q, Q equal to 10W, Q equal to 10W, 10W minus W, straight away 9W. 9W, what is W here? 480 joules you will be getting. 9W, you can substitute 9 into 480 joules. Finally, 4320 joules. This is the change in internal energy. Like this also we can solve the problem. This is the way to solve this problem. This is the question from first law of thermodynamics. This question given in JEE Mains 2023 shift 1. Now, we can have a look on this problem. The pressure of gas changes linearly with volume from A to B. You can see pressure of the gas is changing from A to B. Here increase in pressure and volume decreases. If no heat is supplied to or extracted from the gas, then change in internal energy of the gas is. No heat is supplied. That means heat transfer equal to 0. Here what is given? Heat transfer equal to 0. So we know that Q equal to Du plus W. Heat transfer equals to 0. What is given? Heat transfer equals to 0. They are asking change in internal energy. What is the change in internal energy? Du plus W equal to 0. Then what is the change in internal energy? Du equal to minus W. So in order to calculate work done, what we need to do? We need to calculate area under the curve, area under PV diagram. We need to project the area into x-axis. We need to project the things into x-axis or volume axis. This would be PDV work. PDV work and work done. So I can confidently say that this is what work done. Work done, that too PDV work. PDV work. We need to calculate the area, then we will be getting work done. Then du equal to minus W. That is the procedure we need to solve the problem. Try to solve this problem. Here, this would be area under the curve. We already applied first law of thermodynamics. That is Q equal to du plus W. Here, heat transfer equivalents to 0. From here, we got du equivalents to minus W. So area under PV diagram. This is the area under PV diagram. This will give work done. Work done is nothing but area under PDV. This would be PDV. Area under PV diagram. Area under PV diagram. Area under PV diagram. So how to calculate the area? So it is very simple. Just to see here, we are having one rectangle and one triangle. So I can say that here it would be A1. This would be A2. This is the area. Finally, area work done equal to area A. This would be area. This would be total area. I can say A equal to A1 plus A2. A1 plus A2. So I can say that this would be PA, pressure PA. This would be pressure PB. This would be volume VA, volume VB. So now tell me what is the area A1? How to calculate area A1? Tell me. So area of the triangle. Just observe. What is the area of the triangle? From here to here. I can say that PB minus PA. What is this part? From here to here. I can say that from here to here it would be VB minus VA. This would be VB minus VA. I can say VA minus VB. VA will be higher, right? VA minus VB. What is the area? Tell me. Half into base into height. Half into base into height. So here PB minus PA. Into VA minus VB. What is A2 here? Area of the rectangle. What is the area of the rectangle? So from here to here, I can say PA. This would be from here to here. This would be PA. Okay, PA into What is the area of the rectangle? PA into VA minus VB. VA minus VB. Once you add this both, what is the work done here? What is the work done? Area A1 plus A2, A1 plus A2. Then what you will get, tell me? Once you add these two, is very simple. You can add these two of PA minus, this is PB minus PA plus PA. You can subtract, you can take VA minus VB out. We can take VA minus VB out. You can add these two in this manner. So here, what is the LCM of it? What is the LCM of it? Then PB minus PA. PB minus PA plus 2 times of PA by 2 you will be getting into VA minus VB. VA minus VB. VA minus VB. Finally, what is the work done? Tell me. What is the work done? We added two areas. Then work done. The expression for work done is very simple. Here to here you can draw a line. So here the expression for work done equal to of PA plus PB, PA plus PB into VA minus VB, VA minus VB. Understood na? PA plus PB into VA minus VB. In this manner, we calculated the areas. Now try to substitute the values you will be getting. So area under the curve we got completed. We completed. This would be W equal to. We got W equal to 1 by 2 PA plus PB, PA plus PB into VA minus VB, VA minus VB. What is PA? Tell me. Here it would be PA, pressure at this point, at this state. This would be PB. Here it is VA. This would be VB. This would be VB. Substitute all, tell me. 1 by 2 PA, and PA will be 10 kilopascal plus this would be 50 kilopascal. Kilopascal means kilo Newton per meter square into VA minus VB 200 minus this would be 50 centimeter cube, cubic centimeter, 10 power minus 6 meter cube. So finally, how much you are getting? Tell me. What is the work done here? What is the work done? 1 by 2. This is 60 kilonewton per meter square into 150 into 10 power minus 6 meter cube. 10 power minus 6 meter cube. Here 2 ones are 230. 2 ones are 230. 30. Here how much you are getting? 30 into 150. Okay, so into 10 power minus 6 kilojoules you will be getting. Okay, meter square and meter cube, kilojoules you will be getting. Here 15 3 jam 45 into 10 square into 10 power minus 6 into 10 cube. In terms of joules you will be getting. In terms of joules you will be getting. Finally, what is this? Here it is 10 cube 45 into 10 power minus 1 joule. So here you will be getting 4.5 joule. This is the work done. Now tell me whether it is positive work or negative work. Positive work or negative work? It is positive work or negative work? Compression. It's a compression. Understood na? Compression work is negative because pressure increases, volume decreases. It's a compression work. Compression work assumed to be what? Sign convention. This is the magnitude. Compression work. In compression, pressure increases, volume decreases. In compression, we need to provide the work, power consuming process. Compression is a power consuming process. Work done on the system, negative. This is the negative work. I can say that negative work. So that means W equals to minus 4.5 joule. Minus 4.5 joule. If you apply first law of thermodynamics, we already applied first law of thermodynamics. We got the result. What is that? Du equal to how much? Q, we already know that. du plus W. Heat transfer equal to 0. Here the heat transfer equal to 0. That means here du equals to minus W. Here we know that W equal to how much? What is W? This is minus 4.5 joule. Understood na? So finally we got 4.5 joule. This would be du. du equal to 4.5 joule means what? Increase in internal energy. This is work done on the system. Work done on the system. This is increase in internal energy. Increase in internal energy. Understood na? So internal energy increases. Here work done on the system. Work done on the system. No heat is supplied. Work done on the system. Compression work. Work done on the system. Negative. By that increase in internal energy, no heat is supplied here. So here we calculated two areas, area 1 and area 2. And we added, that is the work done. We got the magnitude of work done. And based on the pressure change and volume change, we need to decide whether it is compression process or expansion process. In compression, pressure increases, volume decreases. In expansion, pressure decreases, volume increases. Conventionally, compression work assumed to be negative, expansion work assumed to be positive. This is the way to solve this problem. Du equal to 4.5 joule. Understood na? 4.5 joule. That is the answer to this question. Here we applied first law of thermodynamics. This is very simple. We applied first law of thermodynamics. Q equal to du plus W. We calculated the area under the curve. Area under the curve. Area under the curve. That is nothing but W equal to integral of PDV. Integral of PDV. Understood now? So in this case, this is the work done. Here work done equal to how much you got? You calculated the areas. Work done. What is the expression for work done you are getting? Equivalence to of PA plus PB. We got PA plus PB into VA minus VB. We got this work done, and here work done equal to, it's a compression work. It's a compression work assumed to be negative. Compression work assumed to be negative. This would be negative. Everything. Here heat transfer equal to 0. That is the given data. Heat transfer equal to 0. Du equal to negative W. So we substituted everything and we got the answer. What is the final answer to this question? 4.5 Joule. Now, we can have a look on the next question. Read the question carefully. A monoatomic gas at pressure P and volume V is suddenly compressed to 1/8 of its original volume. The final pressure at constant entropy. Constant entropy means it's an isentropic process. Constant entropy is mentioned in the question. It's an isentropic process. Initial pressure P, initial volume V, then it is compressed to 1/8 of its original volume. That means final volume will be V1 by 8 or else V by 8. Then they are asking final pressure. Here we need to focus on the monoatomic gas. Monoatomic gas, gamma equal to 5/3. Based on that, we need to solve the problem. Understand the question properly. Write down the given data. See here, for monoatomic gas, gamma equal to 5/3. Initial pressure, P1 equal to P. Initial volume, V1 equal to V. Then it is compressed to 1/8 of its original volume. That means V2 equal to V1 by 8, that is nothing but V by 8. Then they are asking, what is given? Final pressure at constant entropy. Constant entropy process is nothing but isentropic process. Here it is what? Reversed adiabatic process, that is nothing but PV power gamma equal to constant. PV power gamma equal to constant. Gamma is the adiabatic index or specific heat ratio, Cp by Cv. Cp by Cv. For monoatomic gas, generally gamma equal to 1 plus 2 by F. F is the degree of freedom. Here F equals to 3. This is for monoatomic gas. For monoatomic gas. Understood now? So now we can substitute that part. You will be getting 1 plus 2 by 3 equals to 5/3. Understood now? So here this question given in JEE Mains 2022 shift 1. So this is the given data. Isentropic process. For isentropic process, PV power gamma equal to constant is very simple. You can write it as P1 PV power gamma equal to constant, P1 V1 power gamma equal to P2 V2 power gamma. Here P1 equal to P. You can directly substitute P1 equal to P, V1 equal to V power 5/3. P2 equal to, we need to calculate P2 only. What is the pressure? P2 we need to calculate. So V2 is nothing but V1 by 8. I can write it as V by 8 whole power 5 by 3. What is this? Here you can write it is gamma. This would be gamma. This is equal to constant. Understood na? So from that you can write it. 5 by 3 you will be getting. This would be 5 by 3. Now tell me. This is nothing but very simple to solve the problem. Here it is how much? P V power 5 by 3. P2 V by 8. Here I can say that this would be P2 V power 5 by 3 by, I can write it as 2 cube 5 by 3 equal to P2 V power 5 by 3 by 3 gets cancelled out. 2 power 5 will be getting. So here it is equivalent to PV power 5 by 3. PV power 5 by 3. V power 5 by 3 and V power 5 by 3 gets cancelled out. So finally, how much you'll be getting P2? I can confidently say that P2 equal to 2 power 5 P. So this is 32P. P2 equals to 32P. Understood na? P2 equals to 32P. This is the way to solve this problem. Understood? So we applied PV power gamma equal to constant, isentropic process, write down the given data. Very simple to solve the problem. Okay, 32P. So this is the given data for this, and we applied P1. It's very simple to solve the problem. What we did? We are isentropic process in the sense PV power gamma equal to constant. PV power gamma equal to constant. Then P1 V1 power gamma, you can write it as P2 V2 power gamma. P2 V2 power gamma. Here it is what? P1 V1 by, this is gamma. V1 by V2 whole power gamma equal to P2. P2 equal to P1 equal to P. This is what? V by, this is V by 8 whole power gamma. Here it is how much? P 8 power gamma. Here it is how much? P 2 cube 5 by 3. So here it is how much? 32P. This also way to solve this problem. Understood? P2 equal to 32P. Straight away you can answer it. Nothing great here. Understood now? First understand what is happening. Constant entropy process is nothing but isentropic process. Monoatomic gas, gamma. What is the value of gamma for it? Like that we will go through it. Understood now? Yeah. This is all about some problem based on isentropic process. Now we can have a look on the next problem. When a gas filled in a closed vessel is heated by raising the temperature by 1 degree centigrade, its pressure increases by 0.4%. The initial temperature of the gas is, here coming to this gas filled in the closed vessel. Understand this closed vessel concept. In case of closed vessel, vessel is closed and volume is not changing. That vessel means you can need to assume it as rigid. Okay, na? So here volume is constant. Temperature and pressure both are varying. Like that we need to follow. Understood, na? So we need to assume that it is rigid. That is why volume is constant. What is given data? Rise in temperature dt equal to 1 degree centigrade. Increase in pressure, percentage increase in pressure, dp, percentage increase in pressure, 0.4%. Now initial temperature, that would be, we need to calculate. Rise in temperature is given, increase in pressure given, they are asking initial temperature. Now we need to write the given data in the proper manner. Rise in temperature. Rise in temperature means what? This would be T2 minus T1 equals to 1 degree centigrade. Actually, it's a temperature difference. That means 1 degree centigrade equal to 1 Kelvin. Correct na? 1 Kelvin. You should not convert into, you should not add plus 273 because it's a temperature difference. Understood? It's a temperature difference. That means even these two temperatures are in degree centigrade or Kelvin, you will get same answer. Understood? Na? A temperature difference 1 degree centigrade equal to 1 Kelvin. Understood? Na? So now tell me, here I can say that this would be temperature difference. Here I want to write T2 in terms of T1, 1 plus T1. Understood na? T2 equal to T1 plus 1. So percentage increase. What is the percentage? What is the percentage increase in the, this is the percentage increase means dP by P. What is the percentage increase? P original. Change in pressure by, this is the percentage initial, dP by P initial. That is the percentage increase. dP by P. dP by P. That is the percentage increase. I can say that P2 minus P1 by P1. That is the percentage increase, 0.4%. That means here it is how much? Percentage in the sense into 100 equal to 0.4%. So here P2 minus P1 by P1 equals to 0.4 by 100. 0.4 by 100. Here P2 by P1. P2 by P1 equal to P2 by P1 minus 1 equal to 0.4 by 100. So I can say that P2 by P1 equal to 1 plus 0.4 by 100. 0.4 by 100. This is equal to 100.4 by 100. Understood na? So you will be getting like this, 1.004. So finally, what is P2? What is P2 here? What is P2 here? 1.004. 1.004 P1. So percentage increase. This is the percentage increase in nothing but dP by P. We need to write dP by P. Clear? Understood? Very simple to solve the problem. Here, this is the percentage increase, and volume constant, we already know pressure is directly proportional to temperature, dP by P. This would be dP by P, dP by P. Okay. So that is the percentage increase. Clear? Now tell me here constant volume in the sense, pressure is directly proportional to temperature. Pressure direct, here volume is constant, volume is constant, that means V equal to C. Pressure is directly proportional to temperature. Then P by T equal to constant, P by T equal to constant, P by T equal to constant. Then here P2 by, or else you can write P1 by T1 equal to P2 by T2, P2 by T2. So finally P2 by P1 equal to what? Here you can write P2 by P1 equal to P2 by P1 equal to T2 by T1, T2 by T1. So here P2 equal to, you need to calculate temperature T1, you need to calculate. Just substitute everything, you will be getting. So just now we calculated, what is this? P2 by P1 equal to 1.004. Understood? P2 by P1 equal to, here they are asking T1. Just now we calculated P2 by P1 equal to 1.004. And then T2 by T1, what is the T2 by T1? What is T2 by T1? We need to calculate T2 equal to 1 plus T1. Sorry. T2 equal to 1 plus T1. 1 plus T1. Okay. So this is equal to T2 by T1. T2 by T1. Now tell me, what is T1? This is equal to 1 plus T1 by T1. 1 plus T1 equal to this. Here you can write. So from here 1.004 equals to 1 by T1 plus 1. 1 by T1 plus 1. Then you will be getting 1.004 minus 1 equal to 1 by T1. So this is how much? 0.004 equal to 1 by T1. T1 equal to 1 by 0.004. So you can write it as 1000 by 4. So finally equal to 250 Kelvin. 250 Kelvin. T1 equal to, finally T1 equal to 250 Kelvin. Okay. So whatever the answer you are getting from here, that is the thing. So from this relation, temperature must be in terms of Kelvin. Temperatures must be from absolute thermodynamic scale. Temperatures are in temperature are taken from, temperatures are taken from absolute thermodynamic scale. absolute thermodynamic scale, absolute thermodynamic scale, thermodynamic, absolute thermodynamic scale. Understood na? So this is the way. So we have written the conditions and then we applied it. It is very simple to solve the problem. This is P actually. This is P. P only. Understand? Don't feel it as a row. It's a P. P. This would be P. Very simple. Understood? What is the answer to this question? T1 equal to initial temperature. Initial temperature T1. T1 equal to 250 Kelvin. Understood? So this is the data and final answer to this question will be T1. T1 equal to this. So what we did here? So P2 by P1 is very simple. You need to understand one thing. Percentage increase. This would be P dP by P. Rise in temperature, percentage increase in pressure. So you need to understand this. Percentage increase in pressure. Percentage increase in pressure in the sense you need to write like this: change in pressure by original pressure into 100%. That is the percentage increase. Anytime change in that parameter by original parameter we need to write. That is the basic procedure. So this would be final pressure minus initial pressure by initial pressure into 100%. So then you will be getting in terms of percentage. Understood na? So here that is why you have written P2 minus P1 by P1 into 100 you have written, then only you will be getting 0.4%. From here you got P2 by P1 equal to 1.004. So now change in temperature. So rise in temperature in the sense, change in temperature in the sense T2 minus T1. This is the change in temperature. Okay na? 1 degree centigrade is change in temperature. Here you need to remember one thing. This is also very important point. Change in temperature given, in that case Kelvin or degree centigrade both are same. Understood na? So you can straight away write 1 Kelvin. You can write 1 Kelvin here. Straight away write 1 Kelvin. So what is T2 here? T2 equal to T1 plus 1. Everything Kelvin. T1 plus 1. You substituted this part T2 by T1 equal to P2 by P1, P2 by P1, or else straight away you can write what is T1. From here also you can write T1 equal to P1 by P2 into T2, P1 by P2 into T2. So you substituted everything, then we got, you have done some basic level calculations. Finally, we got this. What is T1? From here we can do the calculations, 250 Kelvin. That is the final answer to this question. This is NAT type given in JEE Mains 2022 Shift 2. You need to understand these two things. Percentage increase in pressure. What is the meaning of percentage increase in pressure? What is the meaning of change in temperature or rise in temperature? and temperature difference is given. In that case, degree centigrade and Kelvin both are same. This is the way to solve this problem. Now we can have a look on the next question. Now we can have a look on the next problem. Read the question carefully. 7 mole of certain monoatomic ideal gas undergoes a temperature increase of 40 Kelvin at constant pressure. Okay, the increase in internal energy of the gas in this process is, they are asking increase in internal energy and universal gas constant is given. Write down the given data. Here for monoatomic gas, gamma equal to 5 by 3. Number of moles of the gas, number of moles, amount of gas is given 7 moles. Increase in temperature is 40 Kelvin and universal gas constant is 8.3 joule per mole Kelvin. Increase in internal energy they are asking. For monoatomic gas, here for monoatomic gas, I want to tell you, for monoatomic gas, here I can say that gamma equal to 5 by 3 and Cp equal to 5 by 2 R bar, 5 by 2 R. Here R is universal gas constant. Cv equal to 3 by 2 R, 3 by 2 R. Cp minus Cv equal to R. Cp minus Cv equal to R. 5 by 2 R minus this 5 by 2 R by 3 by 2 R, you will be getting 5 by 3. Gamma equal to 5 by 3. So if you are interested to write this, if you are interested to calculate this, generally Cp equal to gamma R by gamma minus 1. Cv equal to R by gamma minus 1. We can prove it. So it is very simple to prove this. How to prove it? You can take Cv common. This would be Cp by Cv minus 1 equal to R. Here Cp by Cv equal to gamma, then Cv equal to R by gamma minus 1. So it is very simple to prove this. You can take Cp common. If you are interested to prove this, you can take Cp common. 1 minus Cv by Cp, 1 by gamma you will be getting equal to R. Okay na? So this part you can write it as 1 by gamma. Then you will be getting Cp equal to this. Here this part you can write it as gamma. This would be gamma. Understood na? R by gamma minus 1. So now gamma, if you can substitute gamma equal to 5 by 3, straight away you will be getting. If you substitute gamma equal to 5 by 3, here it is what? 5 by 3 into R by 5 by 3 minus 1. Here you will be getting 2 by 3, then 5R by 2. Like this also we can prove it. CPCV, here it is how much? 3 by 2 R. 3 by 2 R. Cp minus Cv equal to R. Like this. Understood na? So now I want to calculate increase in internal energy. How to prove it? So this is du equal to 3 by 2 nr dt. So generally we know that what is Cv? 1 by n dou u by dou t, okay na, at constant volume. Here it is nothing but what you people are getting. You can take for small element or small change in internal energy, you can write 1 by n du by dt. This is the definition of this. Here joule per mole Kelvin. This is the, what is the unit, tell me? Joule per mole Kelvin. This is the unit of CV in this case. Now tell me what is du? I want to write du equal to n CV dt. N CV dt. So just now we proved that generally we know that CV equal to R by gamma minus 1. Here gamma is nothing but 1 plus 2 by degree of freedom. For monoatomic gas, F equal to 3. Then you can substitute 1 by 2 by 3 is nothing but, how much you are getting? 1 plus 2 by 3 is equal to 5 by 3. So this would be R by 5 by 3 minus 1. Here I can say that 3R by 2. 3R by 2. So now substitute du equal to n into 3R by 2 into dt equal to 3 by 2 n r dt. So generally here R is given actually R bar. Okay na? N R bar dt. Here R is given as universal gas constant. So what is the unit of R here? Joule per mole Kelvin. Here this is the unit. What is the unit of this? In terms of joule you will be getting. So this is the way to prove it. Straight away substituting, it's not a big deal. Try to know in what manner these equations are coming. Now we can substitute everything, then you will get the answer. Just observe. I want to substitute that part. You will be getting the answer. du equal to how much? I want to substitute that part. 3 by 2 n r t. Substitute all the units also, then you will get correct answer. 3 by 2, 7 moles into 8.3 joule per, this is what? nr dt. This would be dt, joule per mole Kelvin into 40 Kelvin. So then you can cancel all the units. This moles and this mole gets cancelled out. Kelvin gets cancelled out. Finally, how much you are getting in terms of joule? 3 by 2 into 8.3. Here you will be getting 8.3 into 7 into 8.3 into 40 joule. Okay, so you can cancel it out. 20 will be getting 3 7 jar 21 into 8.3 into 20 joule. Calculate and tell me the answer. Calculate this. You will be getting how much you are getting. Total 2 1 ja, this is 42. 420 into 8.3 joule. Here you can take 42 into 83 joule. So then how much you are getting? 3486. What is the increase in internal energy? What is du? Finally, what is du? 3486 joule. du equal to final answer to this question 3486 joule. Calculate and tell me the answer. 3486. So it is very simple. Generally it is R bar. Okay. So but in intermediate level they are taking R. So based on the unit you can decide. This is the problem based on internal energy, change in internal energy of the gas in a process. Okay, so for monoatomic gas, this is the boss. Monoatomic. If they give diatomic, entire calculations will be changing. This is all about some problems based on thermodynamics. Next class, we will be focusing on numerical session on thermodynamics 2. We can solve some more problems in the next class. Please do subscribe METube INGTEL Physics YouTube channel. Please attend all the classes which you are conducting in METube INGTEL Physics YouTube channel, and please download the app from Play Store. Thank you. We can meet in the next class. Thank you.